morning. Good morning. My name is Lin Kaimeng. I'm represent on behalf of Professor Yuan today. Okay, I will introduce our latest research, revisiting graph analytic benchmarks, and wearing the practicality of graph analytic platforms. Graphs are used in many fields, include social networks, biological networks, and road networks. As interest in graph analysis grows, a number of platforms like GraphX, HowGraph, and others have been proposed. However, choosing the right platform remains challenging. For example, what platform is suitable for beginners and what platform is required for high efficiency? Exciting benchmarks such as Graph 500 and LDBC help in evaluate platform performance, but, mm, but they still have some limitations. First, they focus on a narrow set of core algorithms and often overlook key graph properties like diameter and density. Additionally, those benchmarks emphasize performance metrics while overlooking usability, which is also important for users, especially for beginners. To address this issue, we propose a new benchmark. Um, the framework of our benchmark is shown in the figure. This framework gathers information about the graph platform, generate sensitive datasets, and evaluate the platform using both objective and subjective metrics. For subjective metrics, we use large language models, generate and evaluate code because on platform document, reflecting the platform's usability. Uh, in, in our sorry, in our previous work published in ACM Computing Surveys, a survey of distributed graph algorithm on massive graph. We analyzed the challenges of various graph algorithms in distributed environments, including parallelism, load balance, communication overhead, and bandwidth, and categorized them into 7 topics based on the challenges they addressed. Based on this, we selected our core algorithm set, consider topic diversity, algorithm popularity, and computational workload. Those algorithms cover a wide range of graph processing tasks, which is shown in the right. Besides, our benchmark introduced the distant hope generator, a novel data generator that directly extracts resulting edges, thereby avoiding sampling failures. Besides, to maintain a consistent average diameter, we retract the span of each edge, organize the vertices into groups, and generate edges with each group. So our generator allows for the judgment of 3 key parameters: scale, density, and diameter, making it flexible and effective. This picture shows our result of the uh, the data. Our generator is effective, produce data that mimic real-world distribution. Another contribution of our work is the multi-dimensional evaluation framework, which includes large language model-based usability evaluation and performance metrics. Our large language model-based usability evaluation framework is shown in the figure, which involves 3 steps. Instruction tuning the LLM to understand each platform's API function, and then generating code using multi-level promos, and evaluating the generated code for compliance, correctness, and readability. In the step 1, we instruction turn LLMs using public available data from each platform to train a code generator that produce platform-specific code. In this process, we continue to provide feedback until the generated code meets the platform standard. However, it's challenging to get the large language models proficiency with different platforms. So to address this, we use multi-level promos from junior to expert levels to simulate program with varying skill levels, stabilizing the LLM's understanding. In the third step, the third step involves evaluating the generated code. We have observed that LLM may rely on general coding standards in their training data, leading to a lack of understanding of specific API function in different platforms. So we evaluate the generated code by comparing it with standard reference code. This code are from each platform, assessing its compliance, correctness, and readability. We also describe various performance evaluation metrics used to assess the efficiency and the effectiveness of graph analytics platform. These metrics include teaming, throughput, scalability, and robustness. For our experiments, we evaluated 6 well-used graph analytics platforms: GraphX, PowerGraph, Flash, Grip, Prejo Plus, and Legra. We tested them using sensitive datasets with different variancy. Standard dense with a large density, and time with a large diameter. Okay, in our algorithm and statistics unpack test, we found that interactive algorithms like PageRank and LPA perform similarly on standard and large diameter datasets, but differ on dense datasets. Screenshot algorithms like SSP perform better on dense datasets, but struggle with large diameter ones. As for communicational algorithms like triangle counting or Keyclick, they are sensitive to density, with performance dropping on dense datasets. Those interesting findings are difficult to discover in traditional single-time datasets. Regarding scalability, graph shows the best performance improvement when scaling up with additional threads, while Prejo Plus performed better when scaling out across multi-machines. However, all platforms experienced reduced performance due to inter-machine communication overhead. For throughput, Graph and Pedro Plus consistently achieved the highest throughput across all platforms. Grip and Pedro Plus excel in processing all these skills, while GraphX, Flash, and PowerGraph struggle with larger datasets due to memory or data handle issues. In our usability evaluation, GraphX achieved the highest usability scores across all levels, indicating its user-friendly API design. PowerGraph and Pedro Plus also scored well, especially among beginners, while Grave, Flash, and Ligra shows lower usability scores for junior users, but improved significantly for more experienced programmers. Based on our usability and performance evaluation, we can consider recom recommending different platforms for different user groups. It's difficult to achieve that for traditional performance-focused benchmarks. So in summary, GraphX is ideal for users of all experience levels, provided that performance and scalability are not primary concern. PowerGraph and Pedro Plus are recommended for beginners due to their balanced performance and usability, especially with large datasets. Grave, Flash, and Ligra are best for users with strong performance needed, especially Grave. It be particularly suited for users demanding top performance and scalability, despite a steeper learning curve. In conclusion, we selected 8 algorithms and introduced the distance hope generator, which enhance dataset generation efficiency and flexibility. Besides, we adapt a multi-level usability evaluation framework based on large language models to assess API usability, making the first-time usability evaluation metrics have been introduced in graph analytic benchmarks. Finally, extensive experiments evaluated both the performance and API usability of different platforms, providing valuable insights for users in selecting their appropriate platform. That's all. Thank you.
What are the What are the LLMs and the prompts you use in the experiments?
This is the multi-level promotes used in our framework.
Is that Qianwen or ChatGPT or GPT-4? Okay.
GPT-4.
Okay, and what are the prompts? They are very hard to see clearly. Can you explain the prompts or read prompts? Okay, sure, thank you. And how about the accuracy of the results generated by the LMs? The accuracy, I think it might be a bit hard to generate a clearly and accuracy result or function calling, even if for GPT-4?
Thank you. Because I'm a collaborator of this work, so I can cover a bit of your question because it's leveraging large language model, and accuracy is not quite, and especially it's for subjective evaluation. So I think accuracy is not what we are pursued for. What we are actually pursuing is how it matters human beings' expectation. Because after, can you go to the slides that show the score? Dingkai, could you go to the slides of the score? So yeah, so this is the results that we evaluate using large language model, and the higher score the platform can obtain at a more junior level. That means it's more easier to the end user to program this certain platform. So according to this evaluation, we can see that, for example, GraphX, although it has a very poor performance, in terms of efficiency, but it did have a very good API design for end users. So it satisfied our expectation. And for some very high performance systems, here we benchmark our own work, like Grape and Flash. They don't have very high scores, so that means that our results must be very genuine. Yeah. Well, like Grape, because Grape utilizing the subgraph-centric APIs and make it, you do need a little bit like prior knowledge to get to program Grape, and it is also, quite reasonable. So that's why we believe that it is a good method of evaluating usability, for different platforms.
Do you need to fine-tune this LLM?
We can, but we are not using fine-tuning for now. We just prepare some agents. So there are 4 agents of programmer, junior, intermediate, senior, expert. And then we also have a code evaluator, which is also conducted by large language model. Yeah. But we can definitely fine-tune it to have better performance.